in the last class, we have discussed about attribute selection method, information gain ratio. So what is the difference? Why we are going for information gain ratio? Anybody? We are already having information gain. We are already having information gain. Then why we are going for information gain ratio? Why we are going for information gain ratio? There is a drawback in information gain. So information gain is biased towards selecting the attributes with too many values. That is biased towards selecting multi-valued attributes. So if at all in your data set, if at all the data set is having with many values for a particular attribute, automatically when you are using the measure as information gain, automatically that attribute is selected as the root attribute. Then as a result, too many partitions are made from the data set. Of course, it generates the pure partitions, but having the too many partitions is not required for the classification. So for good classification, for getting the good classification results, that is not the case expected. So the example of that is ID. So in the last class, we have seen about that. If you consider the product ID, if you consider the database consisting of the information about the products, so if you consider the attribute as product ID, it's consisting of the too many distinct values. So in such cases, information gain is not preferable as the attribute selection method. So we are having an alternate, that is information gain ratio. So the drawback of information gain is rectified here, somewhat rectified here, and it is used by what? C4.5 algorithm. And we are having in the last class we have seen about the process of deriving the value of the information gain ratio, and it is nothing but it is a kind of normalization to the information gain with the split information or intrinsic information. So in the last class we have calculated the information gain ratio for income attribute, right? So what are the remaining values you got? Just wait, I'm going to share the whiteboard. So in the last class, we have calculated the information gain ratio for income, right? Income or age in the last class?
Income, ma'am.
Income, ma'am.
Income. What's that value we got in the last class? Any idea? It's 0.019. Yes. Now from numbers 1 to 40, team 1. So make it in an age. Okay. Information gain ratio of age. What's that value? Anyone from? I don't ask the details, how you get that value, etc., etc. Don't worry. Anyone from 1 to 40. What is the information gain ratio value of age? Next, information gain ratio. One more thing, if at all I am not getting any response from any team, attendance of the last class is cancelled, not this class. So మీరు ఆల్రెడీ అటెండ్ అయ్యారు కదా, ఆ క్లాస్ అటెండెన్స్ క్యాన్సిల్ అయింది, ఈ క్లాస్ది కాదు. సో మీరు వచ్చింది ఆ క్లాస్ లోనే కాబట్టి. సో నెక్స్ట్ ఇన్ఫర్మేషన్ గెయిన్ రేషియో ఆఫ్ స్టూడెంట్. ఎస్
మేడం, ఇన్ఫర్మేషన్ గెయిన్ రేషియో ఆఫ్ ఏజ్ మేడం.
ఏజ్ వాట్?
0.0651.
0.0651. Who is talking? What's your number?
Number 6 madam.
Number 6. So you're from group 1, very good. So next, attendance is confirmed for group 1. Congratulations. Okay. Next, information gain ratio of student. What is that?
0.151, ma'am.
0.151. Number 48, right?
Yes,
If
ma'am.
respond number 48. So from
Yes,
team
ma'am.
0.151. Next, information gain ratio of next attribute ichindi. Credit rating. Yes. Credit rating. What's that value? From group 3. ఏదో ఒకటి చెప్తే సరిపోదు. I have the respective answers. Your answer should tally with this approximately at least. Team 3 from 71 to A4. Attendance for 2 teams are confirmed. What is the value of information gain ratio for the credit rating? Anybody have the value or what? Okay. Attendance for the third team numbered from 71 to A4 is cancelled for the last class, not for this class. Okay. So other than this third attribute, credit rating, consider these 3 because we don't have value for this, right? Because no one have come with this value. Okay. And great teamwork. I appreciate a team of third team. Great teamwork. అందరూ కలిపి మంచి teamwork చేసి successful గా fail అయ్యారు. Very good. So let's compare these 3 values. Information gain ratio of income we already have from the last class. Information gain ratio of A's and coming to the information gain ratio of student. So which attribute we need to select from the values we have with us? Which attribute we need to select as the root attribute? From team 3. Anybody? Which attribute we need to select from the values present here? Which attribute we need to select from? Select as a root attribute. Only from team 3 I want to answer for this. 71 to A4. Number 88 unnara? What's your name? Number 88. What's your name? Number 88 is there or not?
Venkat madam. Yes madam, unnanu. Madam.
What's your name?
Venkat madam.
Venkat. Venkat, tell me which attribute we need to select now.
Madam, ipude join ayya madam, chodlu nenu asalu.
Very good. Endu join avadam?
Signal lagi ipude join.
Okay, anybody from other teams also? Which attribute we need to select?
Age madam. Age is selected.
Age is selected. Why age?
More gain ratio ఉంది కదా madam.
More gain ratio age కి ఎక్కడ ఉంది? What is the gain ratio for student? What is the gain ratio for student? 0.151. ఏ attribute కి ఎక్కువ ఉంది gain ratio?
స్టూడెంట్ కి మ్యామ్.
స్టూడెంట్ కి కదా. దాన్ని ఏజ్ ఎలా సెలెక్ట్ చేస్తాం మనం? అంతే కదా. The attribute with the highest information gain ratio, whatever may be the measure, the procedure is same. The one with the highest value of either information gain or information gain ratio or the GINI index, whatever the measure, The attribute having the highest value is selected as the root attribute. So here also, we need to select the student as the root attribute up to the values present here, based on the values present here. But this is not the scenario all the way. If at all you got the same problem in your exam, they may, suppose same table they have given in the exam, they may change the values little bit, they may change and given to you. And you don't remember that for the same example, we got student as the root attribute. So here also the same thing. And we can generate the values like that. Don't think like that. They may change a little bit, any 1 or 2 values, the overall result may change. So the only thing is we need to calculate information gain ratio for each and every attribute. And the one which is getting the highest information gain value, gain ratio value, is selected as the root attribute. That is only the scenario. So here for this example, we have selected the student as the root attribute. And next we are moving towards the GINI index. So in which algorithm, in which decision tree algorithm we have used the GINI index?
Cart, ma'am.
Cart. So we have used that GINI index in cart algorithm. What is the, so GINI index is almost same as the information gain measure. What is the major difference?
It uses
What? 20
binary
XP.
tree కి apply చేస్తాం. Binary tree కి apply చేస్తాం మేడం GINI index.
Yes, very good. So in GINI index, especially we have only generated the binary trees only. Binary trees, that means only one split is there, and only at every stage we have generated only 2 partitions. Whatever may be the level, how many number of levels is the tree is going to grow, that is not the concern here. So at every stage, at every level, we need to grow up to the 2 levels, 2 branches. So that is the constraint with the GINI index, and we have provided some formulas for the GINI index also in the last class. So they are relatively comparable with the entropy formulas and the information gain values, right? So here are the formulas. So if you want to calculate the GINI index for the entire data set, here is the formula: 1 minus sigma I is equal to 1 to n Pi square. Where if you want to calculate the information gain for the split, since we have only 2 partitions, we can directly, instead of sigma, we can directly write this. We can directly expand the formula like this. So this is the way. And finally, what the variance, the uncertainty we have removed can be obtained by removing, by subtracting the GINI index of split, GINI index after the split from GINI index before the split. So the difference between these two is resulted in the total variance we have reduced. So that is the value. So let's consider the same example and let's execute this. Let's calculate the GINI index particular attribute which we have selected. Let me share the screen first. And one more thing before going for the example, one more thing I need to discuss about. Since we are saying that the only criteria, only constraint for the GINI index is binary tree should be generated. So in order to generate the binary tree, out of 3 different scenarios we are having for the attribute selection measures, only 2 scenarios are helpful for us. So we are having 3 scenarios for the attribute selection measure. The first scenario is, I'm going to just rewind the thing again. The first scenario is, if at all the attribute is having the discrete values. If at all is the attribute having the discrete value, then there is a first case. We need to consider the number of values of that attribute as it is. And the second scenario is, if at all the attribute consisting of continuous values, then how we can move forward? If at all the attribute consisting of continuous values, what's the case? Some terminology is there. there is something like some point is there. What point it is? The name of the point is called split point. Do you heard that word previously or not? Split point. We're having split point and splitting subset. Do you remember or not?
Yes, ma'am.
Number 14. Split point and splitting subset is there now, right?
Yes, ma'am.
So if at all the attribute is having continuous value, then we need to take help of the split point, right? Yes, which divides the total data set into two partitions, and that only generates the binary tree, right? So in order to generate the binary tree, we are out of three scenarios we are having, we only have two options here for generating the binary tree. First one is split point. So that is the case whenever the attribute is having continuous values. So what is the other second option we are having? What is the third scenario? Splitting subset. Much better.
Subset.
Yes, splitting subset. So this is the third scenario. What is the splitting subset? Splitting subset. So even if the attribute consisting of the discrete values, but a binary tree need to be generated, then we need to go for the splitting subset, where a set of values for that attribute are formed as a set, and the branching is taken place if at all the attribute's value is belonging to that set or not. For example, if the set is income, low, medium, income values are low and medium, this is the set. So how to partition based on this set? If at all my data values are some x1, x2, x3, so on down. So coming to the tuple, coming to the observation x1, if the income of the x1 is belonging to this category, low and medium, then x1 is partitioned to the left branch. If at all, then consider another tuple x2. If it does not belong to this subset, then it is partitioned into the right branch. So we are having two partitions for the data set. Irrespective of left and right, we are having two partitions for the data set. So if at all the tuples whose income satisfies this subset or fall under this first partition. So all the tuples whose income does not satisfy this subset, does not belong to this subset, they are fall under this second partition. Like this, we have generated the partition. So in these two cases in the sense split point and splitting subset. So these are the only two cases where we can generate the binary tree. So we don't consider the first scenario. We only consider these two cases. Okay, let me share the PPT now. Just go through this slide. So here we are having this is the slide which indicates the three scenarios: splitting subset, splitting criteria, or the splitting point, and a general case, considering the distinct values of the attribute as it is. Just go through this slide once. So like this, now we need to only consider these two cases, right? Sorry. Now we need to consider These two cases. We don't consider the first case. For what? GINI index. For GINI index, we don't consider the first case. So coming to the GINI index is used in CART algorithm, and it measures the impurity of the D as usual, as like previous methods we have. And GINI index considers a binary split for each attribute. And we have two cases here. Case one, coming to the case one, just observe case carefully. Coming to the case one. So if A is a discrete valued attribute having D distinct values, A1 to AB, all possible subsets of A should be examined except power set and empty set. So we should examine all possible subsets, and we should so for a given tuple and for each subset SA, that S is of the form A belongs to SA. Just now what I have discussed in the whiteboard. So the subset that gives the minimum GINI index of A is selected as the splitting subset. So the subset which gets the minimum GINI index. Similarly, in the previous case also, if you consider the information measure, the attribute which is having the, so if you consider the split point, in case of split point, the attribute which is in case of split point, in case of information gain, the attribute which is having the minimum entropy is selected there in case of information gain. Where here the one which is having the minimum GINI index has to be considered based on the measure we have taken. The procedure is same. So the subset that gives the minimum GINI index for A is selected as its splitting subset. So coming to the case 2, that is splitting point. One case is split, irrespective of the order of the cases, one is splitting point and one is splitting subset. So if you consider the case 2, if A is continuous, each possible split point must be considered. So the midpoint between each pair of adjacent values is taken as possible split point. So the point giving the minimum GINI index for A is taken as its split point. For a possible split point of A, D1 is the set of tuples in D satisfying A less than or equal to split point, and D2 is the set of tuples in D satisfying A greater than split point. So coming to the, these are the formulas which we have already discussed, and coming to the exercise. So let's consider income. Let's consider income as the attribute we have selected first, and it consisting of 3 values: low, medium, and high, right? And here is the splitting subset we have selected. What is the splitting subset? Income belongs to low and medium. So what are the elements of the subset? Low and medium. So what are the tuples fall under that subset? How many tuples are there? For which income should be equal to low, either low or medium. How many tuples are there from the data set?
10, ma'am.
11, ma'am.
10 or 11?
11.
Income should be equal to either low or medium.
10, ma'am.
10, ma'am.
10, ma'am.
So we are having 10 tuples under this subset, and remaining 4 tuples belongs to, obviously, right? Out of 14, 10 belonging to this. So remaining 4 belonging to this group, this subset. Income belongs to high. So next, go to the next step. First, what to do? We need to find out the GINI index of the entire data set. So for that, here is the formula: GINI index of the entire data set. So calculate that for entire data set. How to calculate that? We know that the P is the probability of the tuple belonging to the specific class. How many classes we are having? How many classes we are having for the entire data set? For the entire data set, how many classes we are having? So what is the, how many classes are there?
10 మనం ఇక్కడ ఫస్ట్
నెంబర్ 28 ఇప్పుడే నిద్రలేచావా? అక్కడ 10 4 ఆన్సర్ చేసేసారు. నౌ మై క్వశ్చన్ ఈస్, హౌ మెనీ క్లాసెస్ ఆర్ దేర్ ఇన్ ద గివెన్ డేటా సెట్? హౌ మెనీ types of classes we are having?
5, ma'am.
2 classes.
2 classes only we are having. One class is yes and another class is no. Simple, right? How many class labels? Only 2 class labels we are having. That means each and every data set is supposed to fall under any of the 2 classes, not more than that. So we are only having 2 classes. So we need to expand this formula twice. So first consider the S class. So where here P is the probability that a tuple belongs to the particular class. So out of 14, how many S classes are there? Out of 14, how many S classes are there?
9, ma'am.
9 unnaya? 9 S classes are there, and remaining
5 no class.
5 no classes. Simple. So by solving this, we can get the value of the GINI index of the entire data set. So that value is obtained as 0.459. Next, what to do? What is the next step? We need to calculate the GINI index of the selected attribute. What attribute we have selected? Income we have selected. So we need to calculate the GINI index of the income. So here is the formula and here is the table. Let's do calculation. So GINI index of, let's calculate GINI index of the income. How to calculate that? What is this mod D1? What is the value of that mod D1?
10.
10 or 9?
9, ma'am. Number of S classes.
Okay. Before that, I just want to draw a table here. So we are calculating the GINI index not for the entire data set. We are calculating the GINI index for the particular attribute. What is this attribute? Income.
Income.
We need to focus on that only. So we have 2 partitions here, right? So for the first partition, that is let's say D1, and for the second partition we are having D2. Okay. So D1 includes, D1 in the sense, income belongs to
Low.
high, medium, and this is the case of income belongs to low. There are 2 cases. And coming to this is the total. So how many S classes are there in this D1 partition? Otherwise, no need to go. I think no need to go for the details. How many tuples are there in the D1 partition? ఇందాక ఆల్రెడీ చెప్పారు మీరు.
10, ma'am.
10, no?
10,
The
ma'am.
previous value is 10. Yes. 10 tuples are there in the D1 partition, and here 4 tuples are there in the D2 partition, right? So coming to this formula, GINI index of the income is equal to mod D1. Mod D1 in the sense, number of elements in the, number of observations in the D1. How many? How many are there?
10,
Just now
ma'am.
you said
10, ma'am.
by
By
total.
14.
Yes. By 14. Next, GINI index of D, GINI index of D1. Here we need to calculate this, right? Because we just calculated GINI index of the entire data set. We have not calculated the GINI index of the D1. So again, we need to calculate this GINI index of D1. We need to calculate plus again here mod D2.
4 by
What's the
14.
value?
4
by
by
14. Yes, GINI index of D2. So what's our task? We need to calculate GINI index of D1 and D2. So let's again come for the GINI index of D1. Again, which formula we need to consider? For solving this, which formula we need to consider? What is the formula?
1 minus sigma pi square.
Yes, yes. Again, this formula we need to consider. So this is not specific to any attribute. This is the GINI index of the entire data set. That means the data set, not specific to any attribute. This is the formula specific to the attribute, specific to the split. So again, here we need to consider the GINI index of the partition D1 only, not entire data set. Partition D1 GINI index we need to consider. For this, we need to fill this table first. So how many S tuples are there in D1 partition? First of all, let me tick the D1 partition tuples, right? Is this D1?
Yes, ma'am.
Next, tell me the RIDs. 3. Next, 4. 10, 11, 12, right? 13, 14. 10 వచ్చినాయా? So all these are the tuples belonging to the D1 partition. So out of this, how many are belonging to S and how many are belonging to no? Tell me that. How many belonging? Cheppandi.
6s, ma'am. 6s.
6 S. Next,
4, no, ma'am.
4 no. Next, how many in D2 partition? So the observations which doesn't having any tick marks are all belongs to the D2 partition. So in D2 partition, how many S are there? How many no are there?
3s, ma'am.
3 S are there and remaining 1 are yes. Is this right or not? If at all one student respond, remaining students check whether it is correct or not, because you are watching you're not directly watching that, right? You're following through your mobiles. Somebody may get confused. So is this okay? Is this correct data you have provided?
Yes, ma'am.
Yes. Of course, here the totals are matched. So based on this data, we are going to calculate the GINI indexes of D1 and D2. So now tell me how to write here, what to write? GINI index of D1 based on this formula. 1 minus. How many steps I have to expand? How many labels are there? 2, yes and no. Same like previous case. 2 labels are there, so I need to expand twice. I need to expand twice. So here, P1 square plus P2 square. What is this P? Out of total tuples 10 in D1 partition, how many are from S?
6, ma'am.
Yes. Next, how many are no's?
4.
4. So that is the so this value gives the GINI index of D1. Similarly, GINI index of D2. Tell me. GINI index of D2.
3 by 4 whole square plus 1 by 4.
Very good. 3 by 4 whole square. Let me just write it. 3 by 4 whole square by plus
1 by 4 whole square.
1 by 4 whole square. Okay. Thank you. So now we need to calculate final value. ఇండెక్స్ ఆఫ్ D1 చెప్పండి ఎంత వచ్చిందో క్యాలిక్యులేట్ చేసి. మీ phones లోనే ఉంటాయి కదా క్యాలిక్యులేటర్స్. మేక్ ఇట్ ఫాస్ట్. What's the value? GINI index of D1?
0.48, ma'am.
Next, GINI index of D2.
At 0.375.
0.37. Okay, 0.37. So substitute these values in this formula. This is GINI index of the split. Substitute these values here and tell me the value.
Zero point 4476, ma'am.
Okay. So this is the GINI index of the split, and we have the GINI index value in the previous slide. What is that? 0.459.
9, ma'am.
Yes. Now how to find the reduced uncertainty finally? By subtracting the GINI index value before the split. That means the difference between the GINI index value before and after the split. So here is the GINI index value before the split. That is the value for the entire data set. So we need to subtract what? 0.4476 from this value. 0.44. We need to subtract this from this value, and finally we will get the GINI index of the reduced uncertainty by using the measure GINI index for the attribute income by considering the subset low, medium. So what's the next task? Is there any other subset we can draw from this income? So now we have considered the subset low, medium. Out of 3 values we're having 3 values, right? High, medium, low. We are having 3 values. Low, medium అయినా మనం కన్సిడర్ చేసింది హై మీడియం చేసాం.
High medium, ma'am.
Yes. So ikkada okay. This is also okay. Why? Because we need to consider each and every pair of the subsets. High, medium we need to consider. Here out of these 3 values, low, medium we need to consider. This is one pair, one combination. Medium, high we need to consider. Next, this one we need to consider. Totally, we need to repeat the same process for 3 combinations. Actually, in this example, we have considered, we have start expanding for actually low, medium. But in this next slide, I forget that, and we have experimented on high, medium. Did you observe that change? Don't get confused. This is not a problem actually. So we have, till now, we have calculated the GINI index split attribute for the value high medium subset we have calculated. So these are the three possible subsets we can have, right? These are the three possible subsets we can have, and now we have calculated which subset?
High medium, ma'am.
High medium chesam manam. So we have calculated for high medium subset, and don't do this directly. Don't just like what we did it. Don't do this subtraction directly. Before that, we need to do one thing. I forget about that. What we need to do next? We need to go for taking this subset, and we need to we need to repeat the same process, and we need to get the GINI index of the split. We need to get the GINI index of the split. What is that? What is the GINI index of the split? 0.44. Like that, we need to get the values for remaining two also. And out of three subsets, the one which is having the minimum GINI index value has to be considered as the final subset. For example, here we got 0.44 for this, right? 0.44. Suppose, for example, if you got 0.47 here, and for this you may got 0.5. For example, consider. So if these are the values, so which subset we need to consider finally?
High medium.
Which subset? Somebody mute us. It creates a lot of disturbance. Number 59. Okay. So if at all these are the values, for example, for high medium, as we get 0.44 is the GINI index of the split. And for low medium, if suppose 0.47 and high low, it is 0.5, for example. Then what is the final subset we have selected out of three? Out of three, which subset we need to select?
High medium, ma'am.
High medium.
Lowest,
Why? Because
lowest GINI index.
yes.
0.44.
44. So the lowest, the subset which get the lowest GINI index for the split value, we need to consider that only. So we need to subtract that from the GINI index of the entire data set. So a value అంటే ప్రతి subset value ని తీసుకొని subtract చేయకూడదు. First we need to calculate the GINI index of the split for each and every subset. How many possible subsets are there? For every possible subset, we need to calculate. And out of that, we need to select the one which is having the lowest GINI index. Why? Because that should be reduced. Why? Because it represents the variance. The variance of the data set should be reduced. So the one with the lowest GINI index should be considered first, and that value should be subtracted from the GINI index of the total data set. Then you can get some value. Let's say it is X or X1, for example. Now what is the X1? GINI index of the attribute income. Final ultimate GINI index of the attribute income. Next, what to do? Just like here we have selected in right, and in the next test we need to select the attribute A. Just like income, for income we are getting some X1 value as a GINI index, and after that we need to select A's. How many possible subsets are there for A's?
3, ma'am.
Same like
3, ma'am.
Actually 3 values are there. So if at all the attribute consisting of 3 values, ultimately there are 3 subsets, just like here. So what are the subsets? Youth middle age, senior middle age, and middle age senior, right? So like this, we need to again go for each and every subset. So just like this case, for each subset, first what to do? No need to calculate the GINI index of the data set. Why? Because it is already calculated, it is here itself. No need to go again. So what to do? For each subset, we need to calculate the GINI index of the split, like what we did now. And 3 values we got like this. Like this, we can get 3 values again. So what value we need to select finally?
Less
Minimum.
value.
The one with the lowest value we need to select. And after that, we need to subtract that value from the GINI index of the entire data set. Let's say it is x2. Let's say it is x2. And next, what is the next step? I think you know that. What is the next step? What we need to select the next attribute, that is student. We need to select the next attribute, and here only one split is possible because only two values are there for student. So no, only one subset is there, that is yes or no, both are same. Why? Because here low medium subset is nothing but high, both are same. So here also from student we are having subset either yes, either no, both are same. Subset S is equal to subset no. మీరు ఎస్ దగ్గర స్ప్లిట్ చేసినా ఒకటే, నో దగ్గర స్ప్లిట్ చేసినా ఒకటే. వై? బికాస్ వీఆర్ హ్యావింగ్ ఓన్లీ టూ. దిస్ ఇస్ సేమ్ ఫర్ క్రెడిట్ రేటింగ్ ఆల్సో. సిన్స్ వీఆర్ హ్యావింగ్ ఓన్లీ టూ వాల్యూస్, only one subset is formed from that. So again here also we need to calculate the GINI index for that subset, and after that we need to subtract that from the GINI index of the D, and we can get the value as x3. Similarly, we can get the value as x4 for the credit rating. So next, what to do? What is the final selection process? So we are getting 4 GINI index values for the 4 attributes. So now my task is, why we are doing all these things? To select the root attribute. That is also called as the splitting criteria. So to select the root attribute, I am going through all this process. So what may be my ultimate root attribute? Out of 4 attributes I am having, A is income, student, credit rating. What may be the ultimate root attribute? What may be the ultimate root attribute out of these 4?
Attribute having high GINI index.
So out of x1, x2, x3, x4, the attribute with the highest value for the GINI index is selected as the root attribute. So in this class, I am going to give again another exercise for you, but I am providing answers. I am providing answers now. You need to go through all the process, and I randomly call upon some group, and anyone from that group has to share their screen, has to show all the process of calculation. So మీరు మీ నోట్స్ లో చేసి ఉంటారు కదా, అది నాకు షేర్ చేయాలి నెక్స్ట్ క్లాస్ లో. నేను ఒక గ్రూప్ ని కాల్ చేస్తాను, ఆ గ్రూప్ మెంబర్స్ ర్యాండమ్ గా షేర్ చేయాలి. నేను వాల్యూస్ ప్రొవైడ్ చేస్తాను, ఎందుకంటే ఇది కొంచెం లెంతీ ప్రాసెస్ కాబట్టి మీరు టాలీ చేసుకోండి.